Hey, good afternoon, everybody. I think you can hear me. Okay. Okay. We are going to start with the recorded lecture. So you can take out your notes first. Okay, let me go and share screen. Okay, just a note for this recorded lecture, we are actually going to start with the next chapter first. Okay. The whatever we remaining that we have not covered, wait till I'm back. Then we go back to it. So for this recorded lecture, is on a new chapter. Okay, you should be able to see on the screen now. You should also have this set of notes. Okay, the title is called Chemical Equations. Okay, this is a very important chapter. Okay, for a simple reason. In chemistry, you will need to write equations, chemical equations. Okay, pretty much everywhere. Okay, so this will form the fundamentals for every chapter. So I suggest you listen carefully. Okay, on the way, also please go and copy and fill in the blanks. Okay, if for some reason you need to pause this video, you can get the teacher to pause this video for you. Okay, okay, next let's begin. Okay, so before you could even start with writing chemical equations, you need to know the chemical formula. There are so many substances and compounds in this world, it's impossible for you to know all the chemical formulas. So what we're going to do here is we are going to narrow down to the common ones. Common ones, or rather should I say the standard ones that you must know. Okay, for the first thing, first one, okay, I have this thing over here. It's called diatomic molecules. Okay, diatomic molecules. Okay, I don't think I need to explain. It's self-explanatory. Okay, all the examples over here. You have things like hydrogen, oxygen, and nitrogen. On the other hand, all these are group 17. Okay, so in your periodic table, group 17, as long as it's in group 17, it is diatomic. So whenever you know that it is a diatomic molecule, the chemical formula is X2. Okay, where's the highlighter? X2. Okay, where X is that particular element. Okay, I hope so far it's easy enough for you. So in other words, if I were to say what's the chemical formula for nitrogen, it will be N2. What's the chemical formula for bromine? It will be Br2. Iodine, I2, and so on. Okay, the second table, I tried my best. This is the covalent bonding. All the things here are all covalent. Once again, covalent is non-metal and non-metal. So all these things over here is non-metal and non-metal. Okay, so I zoom in. Okay, over here you can see quite a number of it. Okay, the first three are acids. It's a must that you must know. Okay, the chemical formula of acids, for example, hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3. You must know. Okay, these chemical formulas are important, especially for acids. So I've covered acids. Okay. What about the formula of other acids? The one we will not need to worry for the moment, at the moment. But for now, these three acids you must know. Okay, next, I have other covalent molecules, things like ammonia, things like water, carbon dioxide, sulfur dioxide, methane, and carbon monoxide. This whole thing, the list, you must know. Okay, so things like methane, sulfur dioxide, SO2, carbon dioxide as CO2. Okay, so the word di means two. Let me write down, means two. Mono means one. Okay, so one oxygen, two oxygen. So the formula also reflects accordingly. So carbon monoxide is CO, one oxygen, carbon dioxide is CO2. Okay, it's two oxygen. Okay, there's this thing called sulfur trioxide. Yes, sulfur trioxide is an acidic gas as well. Okay, the formula Going by the name tri, it means 3. So the formula is SO3. Any questions so far? Don't have, I hope this is another thing that you need to memorize. If you have already know all these chemical formulas, that's very good. Okay? Okay, I'll move on. Okay. Okay, so now we are done with the covalent. We move to the ionic. Okay, so for ionic compounds, you also need to know the formula. Okay, for example, sodium chloride. Sodium chloride is NaCl. This is the most simple ionic compound. Okay, sodium chloride, NaCl. Again, it's ionic. Okay, for a simple fact, there's metal and non-metal, but it's not always the case. But for quick reference, it's metal and non-metal. I'm my metal sodium, I'm a chlorine non-metal. So together we mean ionic compound, NaCl. So when you talk about ionic compounds, you have charges, ions, okay, ions for positive ions, positive charge, negative ions, negative charge. So the next thing where you need to write the formula, you need to know the charges. A very quick, simple rule is look at the periodic table. Everything under group 1 is plus. So I have Na plus, K plus, Li plus. Okay, so that's good. Again, and group 2 will be 2 plus, Mg2 plus, Ca2 plus. Group 3 is calcium. Group 3 is aluminium, so I have aluminium Al3 plus, and so on and so forth. Okay, group 4, I remember I took. Sorry, I think now it's no longer called group 3. Group 3 is group 13, I think. Group 13 and group 14. Okay, so group 13, 3 plus. Group 14, we don't form ions, so we have left that out. Okay, group 15 is 3 minus, group 16 2 minus, group 71 minus, group 18 the answer is 0. They don't form ions. They are already a noble gas, electronically stable, 8 valence electron in the outer shell, except for helium. Okay, so far so good. So the ions I trust you know. Okay, this one I want to talk about it. I have talked about it many times already. Okay, this is the list of polyatomic ions that you must memorize. Okay. Okay, so let's move on to point number 6. Okay, what is point number 6? Point number 6 are all the ions. Basically, they don't form part of the group 1 to 13, 14, and so on and so forth. They form under transition elements. Okay, things like, for example, silver, lead. So if they don't have a way to memorize not under that particular group, you need to do it this way. It means you force yourself to memorize. So yeah, silver is Ag plus, lead is Pb2 plus, zinc is Mn2 plus. Okay. On the other hand, you will see things like bracket. So this bracket will also translate to the charge. So I have iron 2. Iron 2 is Fe2 plus. Iron 3 is Fe3 plus. Okay. I also have such thing called copper 1. It's just that it's not so common. But yes, there's copper 1, Cu plus. Copper 2, Cu2 plus. Can. So far so good. Okay. Let's move on. Okay, so once you know the positive charge and the negative charge, you can put them together. That is your ionic compound, and you can write the formula. So let's start with the first example, number 1, sodium chloride. So for sodium chloride is Na plus Cl minus. Okay, so when you put them together, you realize that I have 1 Na plus and 1 Cl minus. So the charges are equal. Okay, the charges are equal. Okay, what do I mean by equal? It means one positive is balanced with one negative charge. I have one positive charge from the sodium, I have one negative charge from the chloride, one positive, one negative, they are equal. The answer will be NaCl. Okay, the second example, magnesium oxide. The cation ions are magnesium and the anions are oxide, O2 minus. So then again, it is again balanced because the charges are equal. 2 plus, 2 minus. They are both equal. Okay, so the net will be 0. So that's why your formula is MgO. You write the metals first. Okay, Mg followed by O. The third one is calcium chloride. Okay, so for calcium chloride, the formulas, the ions are Ca2 plus and Cl minus. So if I do write down for you over here, I Ca2 plus and Cl minus. You realize the charges are not equal. I have 2 positive, but I only have 1 negative. So in this case, I will require another one more chlorine, or rather one more chloride. Okay, so now I need 2 chlorides. So there are 2 negative charges in total to balance the 2 positive charges. So the formula will become CaCl2 because I needed 2 chloride. Okay, CaCl2 over here. Any question? I hope not. Okay, okay. Okay, next I have lithium oxide. Okay, lithium oxide, you must know lithium is Li plus because it's group 1. All group 1 is Li plus. You will lose 1 valence electron for obtaining the stable electron configuration of a noble gas. So for lithium oxide, same thing. I have Li with a single positive charge. Then my oxide is 2 minus. Then you realize the charges are not equal because I have 2 negative, but I only have 1 positive. So actually, I need another lithium. So in total, I have 2 lithiums. So the formula is Li2O. Any question? Once you have understood this part of the concept, how many positive, how many negative you need, you are on good track. Okay, next, polyatomic. That's the table I told you to remember as many times, the polyatomic ion. Okay, so same. So we talk about polyatomic ion, it's still an ion. Polyatomic ion obviously is an ion. So it will have all charges that you should have memorized. So in the case of the magnesium sulfate, okay, the formula of magnesium sulfate is MgSO4. Why? Because you can write down I have Mg group 2, charge is 2 plus, 2 positive charges. My sulfate is SO4 2 minus. Okay, bear in mind, the charge is 2 minus, not 4 times 2 minus. No, just 2 minus. Together, the entire SO4 has a charge of 2 minus. So if you look at it, okay, I have 2 plus, I also have 2 minus, they are both equal. So my formula is I just need one set of Mg and one set of SO4. So the answer is MgSO4. Okay. Okay, the next one, calcium nitrate. So for calcium nitrate, the charges are calcium is in group 2, it will be 2 plus. Nitrate you have memorized in the polyatomic ion is NO3 minus. So you look at it, it's not equal. One is 2 positive, the other one is only 1 negative. I repeat, it's 1 negative. The NO3, the 3 does not play any significant role to the charge. Together, NO3 represents 1 negative charge. So it's not equal. I need 1 more NO3. And that's why the formula now is Ca, 1 Ca, and 2 sets of NO3. So I need to put a bracket. Okay, if you don't put a bracket, you put CaNO3 and the 2, it becomes CaNO32. That's not correct, huh? So you will need to put a bracket. Understand? Okay. lithium carbonate. Okay, for lithium carbonate, let's look at the charges. The lithium is Li plus, the carbonate CO3 2 minus. So since they are not equal, I need one more plus. So I put Li plus. So the formula now will become Li2, because I do need 2 lithium followed by a carbonate, which is CO3. Just one set of carbonate. Okay. Okay, ammonium oxide is the only positive poly poly atomic ions. So the formula, you go and take a look. I need 2 sets of ammonium. So that's why I NH4 plus and another NH4 plus. So that I have 2 positive charges to balance my O2 minus. So you put down a bracket, you need to put a bracket NH4 bracket 2, which is O. And questions about no. Okay, no. Can I get you to try this out? Okay, this video continue run. Okay, but you'll continue to run for the next 5 minutes. Okay, can. So yes, 5 minutes. You are given 5 minutes to complete this task. Do it on your own. Okay, if you need a periodic table, go and get a periodic table. I'm sure you have one in your file. Okay, the 5 minutes starts now. Okay, the first one very easy lah. I write down for you. The rest you continue. You're left with about 1 minute. Okay, that's the total of 5 minutes. Okay, let me run through the answers so far. Okay, for sodium chloride NaCl, this one let me explain. Potassium chloride KCl, also very straightforward. All these, the positive and negative, they are already equal. Magnesium oxide, calcium oxide, CaO, they are equal. Okay, number 5 onwards, you realize I need one more fluoride, because fluoride is negative, calcium is 2 positive. So that's why I need one more fluoride. Potassium sulfate, the formula is K2S. You realize potassium is K plus, but I need one more K plus. To give me 2 plus in total, because my sulfur is 2 minus. Okay, sodium oxide is Ne2O, because I need 2 sodiums. Because my oxide is 2 minus, I need Na plus and another Na plus. Iron 2 chloride, so that's why you know what's iron 2 chloride. The bracket 2 means 2 plus. So 2 plus, you need 2 chlorides, because each chloride is Cl minus. So Cl minus and another Cl minus. So I have 2 negative together with my Fe2 plus. Iron 3 chloride, same story, FeCl3. Iron 2 oxide means Fe2 plus. Because it's iron 2 oxide. Oxide is 2 minus. So they are really equal. 2 plus, 2 minus. The answer is just FeO. Iron 3 oxide, you'll realize that it now is Fe3 plus with O2 minus. Okay, you realize that to make them equal, you need 2 Fe3 plus. 2. That's why the answer is Fe2O3. 2 sets of Fe3 plus. You will need 3 sets of oxygen. So the total is 6 plus, 6 minus. So in total, 2 Fe's and 3 oxygen. So 6 plus 6 minus. So answer is Fe2O3. Okay, the next one is zinc chloride. Zinc is Zn2 plus. You should have, if you have forgotten, you go back to the previous part of these notes. The earlier part of this set of notes. Zn is 2 plus. Okay, so that's why my zinc sulfide ZnS, they are really equal. Okay, now we move on to the polyatomic, which is NaNO3. So far, so good. They are really equal. I have 1 Na plus and NO3, 1 minus. So plus and minus are equal, NaNO3. Magnesium carbonate is also equal. Calcium carbonate is also equal. Okay, for potassium, it's not equal. You need 2 potassiums. Okay, because each potassium is only 1 plus. So you need 2 sets of it to give 2 plus to balance by 2 minus. CO3 is 2 minus. Iron 2 hydroxide, the formula is Fe. You need a bracket because you need 2 sets of the hydroxide. Every hydroxide is only 1 minus. So I need 2 hydroxides. Okay. This one I need to put a bracket also. And the bracket is 3 because I need 3 hydroxides. Because Fe3 plus, I need 3 minus. So I need 3 sets of the OH. Zinc sulfate. zinc sulfate is already balanced. So it's there as 4. Sodium sulfate, you need 2 sodiums, Na2SO4. Ammonium chloride is NH4. Ammonium is NH4 plus. I just need one of it because Cl is minus. So 1 plus and 1 minus, you already equal. Ammonium oxide, I need 2 sets of ammonium and H4. 2 sets followed by oxygen. I think you know why I need 2 sets. Ammonium sulfate, I also need 2 sets. Ammonium sulfate is the ultimate because it's got 2 polyatomic ions inside. It's ammonium and sulfate. Okay. The last one is aluminium oxide, is Al2O3. I purposely put it there to check whether people got tricked. It's aluminium, Al2O3. Why is it Al2O3? Aluminium is 3 plus. Oxygen oxide is 2 minus. So you balance. I mean, you need 2 sets of this to give you 6 plus. And you need 3 sets of this to give you 6 minus. So the answer is Al2O3. Any question? Okay. Can so far so good. Okay. This question we have done it before, I remember. Okay. I hope by now you will make it easier for you. This is Na plus. Okay. Yes, and this whole thing will mean is ClO2 minus. This will mean is Cl3 plus. And this will mean is SO4 2 minus. Sulfate is SO4, remember, so that's why SO4 2 minus 4 Tl3 plus. The formula is Tl2 SO4 bracket 3. So that's why 6 plus is minus. So need 3 sets of that and 2 sets of the Tl3 plus. Okay, so now the question is thallium chloride. So my thallium chloride is thallium. And so you need to put together, the answer is Tl bracket 3 sets. I need 3 sets of chloride. Okay, so ClO2. Yeah, this is the answer. So it's B. Any question? No. Okay, very good. Let's move on to the next set of notes. Okay, so now we talk about chemical formula. We are all done already. All the chemical formula, what sodium oxide, ammonium sulfate. Okay, so now you've got chlorine Cl2, water H2O. So you know all the chemical formula, okay, of the substances. Now you put them together, you have an equation. So what is the equation? The equation, point number 1. Make sure you turn to any cell already. Point number 1. The equation shows you what are the reactants and what are the products. I think you know what is reactor product. Reactants are things that react together. Products are what is formed at the end of the reaction. Okay, and the relative amounts, how many of these you need, how many of that. Physical state, is it solid, liquid, and gas. Okay, the examples over here. These two are the reactants. Okay, and this one is the product. Okay, so the equation over here, sodium reacts chlorine. I get sodium chloride. The first one is a word equation, followed by a chemical equation. Okay, so next question, I need to balance the chemical equation. Okay, what do I mean by balancing? Balancing means they must have equal numbers of atoms for each element on both sides of the equation, means the left hand side as well as the right hand side. Okay, so not to worry, you don't understand what it's talking about. Okay, I have an example over here at the bottom. So this is hydrogen. This is hydrogen, and there's oxygen. Okay, and of course this is water. You should recognize their chemical formula. Okay, so hydrogen, oxygen, water. So my hydrogen is H2. Okay, my oxygen is O2. They are all diatomic. My water is H2O lah. Okay, so you realize, okay, first of all, the reactors are written on the left hand side of the equation. Yes, correct. So my reactors are hydrogen, oxygen. They will react to form water. Next, my products are written on the right hand side. Yes, water is my product. So I form water at the end. So it will be written on the right hand side. Next, you realize that it's not balanced. Why? You check. I do not have the same number of oxygen on the left as well as on the right. So oxygen on the left, there are 2, because it's O2, but I only have 1 oxygen on the right because it's H2O. There's only 1 O. So we need to balance this equation, which we will talk about immediately after this page. Okay, then the next one, state symbol. You realize there's a bracket G, bracket G, bracket L. What are those? Okay, so over here, bracket S is solid. Okay, bracket L is liquid, bracket G is gas, bracket AQ is aqueous. Let me ask teacher, what is aqueous? Okay, the meaning of aqueous means I dissolve some substance into water to form an aqueous solution. Okay, liquid is liquid, like water is L, liquid, because I don't dissolve anything. Water is just water. I never put things inside to dissolve. Okay, can. Okay, let's move on. So let's start with balancing. This was the earlier equation. I have hydrogen and oxygen. They both react to produce water. So you can write down the chemical formula. Diatomic for H2, diatomic for O2. Water is just H2O. Then I realize that the atoms are not equal. They are not equal on both sides of the equation. So this is a table that you can tally. I have 2 hydrogen on the left. I have 2 oxygen on the right. Sorry, on the left. So I H2, 2 hydrogen, O2, 2 oxygen at the start, which is on the left hand side of the equation. Then on the right hand side of the equation is water. Water is H2O. So I have only 2 hydrogen and 1 oxygen. You realize that oxygen is not equal. Hydrogen, yes, they are equal, 2 and 2. But however, oxygen, left hand side got 2, right hand side only got 1. So you realize that the oxygen on the right hand side is not enough. Okay, so we need to increase the oxygen here. This is not enough. So how? I have to increase the number of H2O, which is I need to increase the number of water molecules. So to do that, I insert a 2. This is in front of the chemical formula. I realize in front, so you put a 2 in front of it. Okay, so when you put 2 in front of it, what does it mean? It means I have 2 sets of water. So that's why your numbers jump. I have 2 oxygen now, but I have 4 hydrogen because 2 sets of H2O. Every set of H2O got 2 hydrogen. Now got 2 sets, means you got 4 hydrogen. Okay, your oxygen, you have 2. So you look at the table again. On the right hand side, the oxygen looks fine. Okay, I have 2 oxygen on the left hand side. I also have 2 oxygen on the right hand side. So the oxygen looks fine, but because now my hydrogen has doubled from 2 to become 4, my hydrogen is not balanced. So I have to work something about hydrogen. So I will need to balance it so that it is the same. So I inserted another 2 in front of the hydrogen. So that gives me 4 hydrogen now. 2 sets of H2 means total of 4 hydrogen atoms. So if you look at the table and you check through everything, they are balanced. So that is the correct, and that would be the chemical formula. 2H2 plus O2 give you 2H2O. This will be my chemical balance, chemical equation. Okay, it's here lah. It will be written for you. Any question? No? Okay, let's talk about state symbol. Okay, solid, solid, liquid, liquid, gas, gas lah. Aqueous means you dissolve something in water to form an aqueous solution, then you put AQ. Aqueous. But bear in mind, not everything can be dissolved in water. I think you learned that before. Okay, so next I have this thing called state symbol. So let's run through each of them one by one. So for the first one is solid state, bracket S. Where do I put solid state? Okay, when number one is a metal. Okay, at room temperature and pressure, metals are solid, except for a few exceptions. Mercury is one of them. Okay, don't ask me what other elements are after other than mercury they are. Just that you have not learned them yet. Okay, so metals, you have all the metals, aluminium, iron, zinc, all these are metals. They are all solid at room temperature. So just put bracket S for state symbol. Next one is insoluble things. That means things that cannot dissolve in the water. You may ask, so how know which one cannot dissolve, which one can dissolve? Well, I will show you what to do with that later on, okay? But for now, insoluble things that cannot dissolve, obviously they will remain as a solid. You cannot dissolve, so it stays as a solid. Things like carbon, yeah, which is a non-metal, carbon, sulfur, all these are non-metal, but they cannot dissolve water. Other things like silver chloride, copper 2 oxide, all these are compound. They cannot dissolve water. How do I know? Because I'll share more. Okay, liquid state is L. Just put L. L is for liquid. I think it's very clear cut. Pure water, pure water. I repeat the word pure, pure water. So pure water means just only water. Nothing is dissolved inside. So it's L. Just pure water is liquid. Anyway, water is liquid. All of us know. Okay, next, molten metals. What is the meaning of molten? Molten means you melt. Melt. I think I've talked about it before, like molten. Melt. So I have iron, which is solid at room temperature, but if it's very, very high temperature, it will melt. Okay. So you can have molten iron, molten aluminum. Okay. Next one, gas. Gas, you know what's gas lah. Don't need to talk about it. All the gas. Then water vapor. All these are gas, food, bracket G. Okay, and the last one is aqueous. So basically, if it doesn't belong to any of the first three, then it must be aqueous. Aqueous are things that can dissolve water. Things like sodium chloride. Sodium chloride can dissolve water. Sodium chloride is the salt that you eat at home. Can dissolve water. Okay? So far so good. So far so good. Okay. So this is it. So I add in the state symbol for each of them. Bracket G, bracket G, bracket L. This will be the final chemical balance chemical equation with state symbol. Can we do a practice? This one, how long you need? Let me think. Last time I give 5 minutes. And got people can finish. Okay, so I give you 5 minutes also. Okay, you try. If you can finish in 5 minutes, you genius. Okay, let's start. The 5 minutes start now. You can continue. This video continue to run. Don't need to pause. Okay. Okay, I hope you are halfway through the questions. Okay, I'll give you the answer for the first one. The first one, very simple one. Okay, it's 2CO plus 1 oxygen. Give me 2 CO2. Okay. You can double check. 2CO plus 1 O2 give you 2CO2. There are 4 oxygens on the left hand side. There's also 4 oxygens on the left hand side. Yeah, left you about 2 minutes. Anybody finish already? I don't think so, right? Okay, continue. Okay, 1 last minute. Okay, the time now is 5 minutes. Okay, I'll go through the answer. Okay, it may be too fast for you. Okay, if that's the case, we need to rewind the video. Okay, so let's go on to the second one. So I written down a special rule. Okay, this special rule is very special and very important. It will save you your life. Okay, this special rule is you balance oxygen and hydrogen the last. Okay, later I'll explain why, but just follow for now. Okay, so for second one, I have nitrogen, hydrogen. All the chemical formula are given: diatomic, diatomic, ammonia is NH3. So you will balance hydrogen last. Okay, so let's balance nitrogen first. So I have 2 nitrogen. Okay, and I need 2 nitrogen on the right hand side. So let me write 2 nitrogen on the right hand side. So nitrogen is done. I now move on to my last one, which is hydrogen. So let me check hydrogen. I have 2 hydrogen on the left by 6 hydrogen on the right. So to get me my 6 hydrogen that I need on the left also, I put 3. So that is 6 hydrogen and 6 hydrogen, both on each side. Okay. And I double check nitrogen also 2 on each side. So everything's done. So okay, put down number 1. Okay. If you don't put down a number, it will be blank, I'm fine with it. Okay. The next one. Okay. Cl, MgO, MgCl2, H2O. I don't know whether you recognize this equation. This is acid react with base, giving salt and water. Below side equivalent acid react base with salt water. So never mind, let's move on to balance. As usual, hydrogen last. So oxygen also last. So I choose to balance the magnesium first. So magnesium, I check Mg, is already balanced. So I'm left with Cl, the next one. So I check the Cl, chlorine. I realize I need to put 2 over here to give me 2 chlorine. Correct? 2 chlorine. So that the right hand side also already got 2 chlorine. Left hand side must have 2 chlorine. Okay, so my magnesium is done. My chlorine is also done. I have oxygen, hydrogen. Okay. I check my hydrogen. It's also balanced. Correct. Yes. Plus 2 hydrogen from the HCl. I have 2 hydrogen. From the H2O, I also have 2 hydrogen. So hydrogen is done. Oxygen is also done. So this is the answer. Okay. Okay, the next one, question number 4, is also acid react alkali with salt and water. Okay, over here, I'll start with sodium. Okay, I'll leave oxygen, hydrogen to the last. Okay, why do you leave hydrogen and oxygen to the last? For a very simple fact, you can see that every chemical formula here involves hydrogen, except for sodium sulfate. So I also make hydrogen here, there, everywhere also hydrogen. If you start hydrogen, it's going to make it very difficult because when you write one thing, one number, you affect quite a lot of things. Okay, so there are hydrogen everywhere. So just settle the rest of the things first before settle hydrogen. So having said that, I will settle my sodium. Next, I move on to oxygen. Okay, you realize my oxygen is not balanced. I need to write a 2 over here. By writing a 2 over there, I will get 6 oxygen. 4 from the sulfate and 2 from the water. So 6. Check my left hand side is also 6. Okay. So I done with oxygen. I done with hydrogen. And hydrogen also done just nice. Okay. So check hydrogen is done, oxygen is done. Hydrogen has 4. 2 from sulfuric acid, 2 from sodium hydroxide. Okay, 2 sets of sodium hydroxide. So there's 4 hydrogen. The other side also has 4 hydrogen. So everything is done. So the answer is like that. Okay, next one. I'll move a bit faster. Check carbon is done. Next, I check hydrogen. Okay, I don't do oxygen first because there's a lot of oxygen everywhere. I just need to settle hydrogen first. Hydrogen only got one thing here, which is methane. The other thing there is water. So I balance the water, H2O. I give me 4 hydrogen. So my hydrogen is done. Next, I like oxygen. You will check, you need a 2 here. Okay, side 4 oxygen on the other side. So this is also done. Okay, the next one. HNO3, CaCO3, and whatnot. Okay, well, you realize there's so many things over here, and everything of them have oxygen. So let's move oxygen to the last. Okay, check calcium. Calcium is balanced. Let's check nitrogen. Okay, you realize nitrogen is not balanced. You need to put 2 over here. Okay. Yep. So after that, my nitrogen is done. My calcium is also done. My carbon is also done. Okay, so I only left O and H. So let's take a look at H. Okay, my H is also done. Very good. Let's take a look at O. I can tell you the O is balanced. I can work out the number 6, 7, 8, 9. 9. Yeah. Okay. Yes, 9 oxygen on each side. So it's really balanced. So yes, very good. That's the answer. Okay. Next, I Fe2O3 plus CO give Fe and CO2. Oh, this one is tricky. Okay, I oxygen everywhere. I leave oxygen last. Let's balance iron first. Okay, I have 2 iron now already. So iron is done. Carbon also done. So that's oxygen. Okay, so how to do oxygen? You check on the left hand side, there's 4 oxygen. Correct. So I need 4 oxygen also lah. So I put a 2 here. That give me 4 oxygen. So oxygen is done. But then my carbon now is not done. My carbon, I have 2 carbons. So I need to balance the 2 over here, 2 carbons. But then if I do like that, you realize, yes, although my carbon is balanced already, now my oxygen is not balanced. Why? Because I have 5 oxygen atoms, 3 plus 2, but I only got 4 oxygen atoms. So obviously, oxygen is not enough over there lah. So I must change this number to become 3. So by changing it become 3, I will now have 6 oxygen. So let me try to make it 6 on the other side. So by changing this, I need to change this to 3 as well. So I have 6 oxygen. So my oxygen is done. Okay. Yeah. So because you keep changing the oxygen, you also affect carbon. So you check, that's nice. 3 carbon, 3 carbon. So carbon is also done. Oxygen is also done. Iron is also done. So this is the answer. Okay. Any question? The last one. Oh, the last one is the ultimate. We call it the ultimate. Okay. So I start with carbon. 3 carbon. Don't start with oxygen, hydrogen yet. So that leave it to the last. So 3 carbon, 3 carbon, done. Okay, next I do hydrogen. Okay, because hydrogen only got 2 things, one on the left, on the right to settle. Oxygen is almost everywhere. Okay, so hydrogen, I put a 3 here. So I have 6 hydrogen, 6 hydrogen. Okay, now I like oxygen. I believe those who have reached under this question, you will find this question very irritating. Okay, why is it very irritating? Okay, later you'll know why. So I have 2 oxygen over here, but I have how many? 6. 3 plus 2 is 6. 3 plus 2 is 6. 6 plus 3 is 9. I have 9 oxygen over here. You must be thinking, how? Play with the numbers. You can play with the numbers, but it's not so easy to play with the numbers lah. Okay, let me teach you a method that's very fast. Okay, first, I need to change this to 9 oxygen. Okay, so find any question. Okay, this method, a shortcut, is only applicable if the left hand side only have one reactant that has oxygen. So in this case, this does not have oxygen, so it's not going to affect me. I only the C3H6 don't have oxygen, so I only have 1 oxygen there for me. So yeah, so I'm going to use this method to change it to 9 oxygen. I put a fraction 9/2. I think no fraction very well, right? 9/2 times 2 will give 9. You can go and do your math. 9/2 times 2 is 9. Okay, so now I have 9 oxygen. Yes, my oxygen is balanced. My carbon I have 3, it's also balanced. My hydrogen I have 6, also balanced. Okay, very good, everything balanced. But of course, you cannot leave leave your answer in fraction. So what am I going to do next? It's very simple. I will remove the denominator. How do I remove the denominator? I'll just multiply 2 throughout. So this one becomes 2. This one will become 9. This will become 6. This will become 6. So this is the correct final answer. You can double check. Carbon, there's 6 carbon. Hydrogen, there is 12 hydrogen. Oxygen, there is 18 oxygen. Yeah, you can go and find that 18 oxygen for yourself. So this is the answer 2966. Can let me see, can I skip all this up? I will. Okay, since you got state symbol, let's not skip. Okay, this is a past exam question. So how to do? Okay, first of all, let's write down step by step. Sulfuric acid is H2SO4. So we do you go memorize. Okay, calcium carbonate. Calcium carbonate is what formula? Calcium carbonate is this. How I know? Because calcium Ca2 plus, carbonate CO3 2 minus. They are already equal. So the formula is CaCO3. Okay. Okay, next. What is this? So acid with carbonate. Acid with carbonate give me what? Acid with carbonate give me what? Give me salt, carbon dioxide, water. So the lower side, lower side. Acid with carbonate give me salt, carbon dioxide, water. So the carbon dioxide CO2, the water is H2O. What's the salt? The salt is called calcium sulfate. If you are very good in those, you know what I'm talking about. Okay. If not, you just follow for now. So answer is calcium sulfate. Calcium sulfate is CaSO4. Why is it CaSO4? Okay, very good. Ca is 2 plus, SO4 is 2 minus. They are really balanced, so CaSO4. Okay? Okay. So I've written down everything. Chemical formula. Let's talk about balancing the chemical equation now. I think it is already balanced. Yeah. So don't need to try to crack your head so hard. It's already balanced. Next, state symbol. Let me change my color. Okay, state symbol. Water. We definitely, I say many times already. Carbon dioxide is gas, obviously. Okay, then acids. All acids are equals. Okay. Just remember, all acids are equals. Calcium carbonate is a solid. Okay. Why is it that so? We'll talk about it later. Calcium sulfate is also solid. Okay. Yeah. Why is it so? We'll talk about it later also. Okay. Can. If you're wondering why, a simple reason is insoluble. That's why it's solid. How do I know it's insoluble? We'll talk about it. Okay. Okay, next one. What is this? Why so complicated one? Okay, let me change back to the blue. Right equation. What is this equation? I want to get molten tin and carbon monoxide. So something plus something gave me molten tin. Tin is Sn. Yeah. Yes. That's in the period that we're going to find. Okay, tin is Sn. If not, you can get a hint from here, SNO2. Okay, and carbon monoxide is CO. So something plus something give me tin and CO. Okay, so what is it? So I have my SNO2. The ore itself, like cassiterite, SNO2. Then they say I need to reduce it with carbon. Yes, carbon. So plus carbon. Okay. Then now what? Now you write the equation. Okay. So you write the equation finish, you balance. So how to balance? I balance the tin, SN is already balanced. Okay, very good. I balance the carbon, so balance. So I have oxygen. So I do oxygen last. So I put oxygen, I put 2 here. that will affect my carbon also. So I need to check my carbon. I put a 2 here. So that's the answer lah. They never ask for state symbol, so don't put state symbol. Okay? But if you are very curious about state symbol, I can tell you the answer lah. This is solid. How do I know? Because it's ore. You dig it from the ground, obviously it's solid. Okay, it's ore. The carbon is solid. Carbon solid. At room temperature. Okay, next. This is a metal. Okay, it's a metal. I repeat, tin is a metal. I think you know. It should be solid. However, because of the question stated molten, is L. I check my notes. I can say what molten means L. Okay. Then liquid was to melt the metal become liquid metal. So liquid molten tin. This is carbon monoxide. It's a gas. They always say it's a gas. Okay. Wow, what is this? You're gonna skip the long story. We are just going to focus on the equation. The story you come back to in a while. Next time. Okay, this is what acid we have hydroxide. So my formula for my sulfate is H2SO4. You better go memorize if you don't know. Barium hydroxide. Oh, barium hydroxide. I don't know whether you know what's barium hydroxide formula. Yeah, it's this one. Hydroxide is OH minus. I need 2 hydroxides because barium is 2 plus. I know it's barium is 2 plus. You check your periodic table. It's in group 2. So it's 2 plus. So I need 2 sets of the OH. So the BOH. Okay, anyway, what's to do after this? This is acid react with base. Sorry, acid react alkali because it's soluble. Acid react alkali. Okay, so what do I get? Acid react alkali, salt and water. You learn low set. So my salt is barium sulfate and water. Yeah. Wow. There you get balance. Okay. To cut the long story short, I put a 2 here and it should be a balance. Okay. Yeah. Okay, next, they want state symbol. Okay, let me go and find state symbol. Okay, all acids are equals. This one I already say. This one is equals. How do I know? The question got say is equals. This one is solid. How do I know? I don't know whether the question got say, but yeah. Oh, sorry, the question got say so good. Okay. So insoluble, solid. Water is liquid. Can. I may adjust already. Okay. Can. Okay, very good. Okay, let's move on to the okay, let's go to the ion equation. I tell you, this is your most ultimate nightmare equation. Ionic equation. I think it's only available in pure chemistry. Yeah, correct. Yeah, I don't know how much time left. I think about half an hour. Okay, let's go. Let's go. Yeah, let's go. Okay, so I cut the long story short. I just go straight to the point. Okay, I have so many equations. Okay, word equation. I think you know what's a word equation. It's here. Word equation. Word equation means got word. Chemical equation. Okay, what's chemical equation? Chemical equation is chemical equation and chemical formula inside. Ionic equation. What's ionic equation? Ionic equation is new. This is what I'm going to do for this part of the lesson. Ionic equation is for ion. Okay, but to be more specific about ionic equation, the ionic equation is not just about ions. It's about ions that are specifically reacting. There's also anything called spectator ion, which we'll talk about it later. You don't know what's spectator, right? It's okay. Okay. Yeah. So you must know the difference between equation. They ask you write word equation, write word equation. They ask you write chemical equation, write chemical equation. They ask you write ionic equation, ionic. Okay, so basically, how do I get the ionic equation? You will start with the chemical equation. So if you don't know how to write chemical equation, that's too bad. Okay, we have just went through a whole thing about chemical equation and the state symbol. Okay, so let's start with this. Okay, this is acidic alkali or acidic alkali solid water. This is what you learn in lower sec. So acid alkali is salt water, so I have ACHCl. So that the outside is the alkali and it's also you first write this equation, check it's balanced. Is it balanced? Is it balanced? Is it balanced? Is it balanced? Yes, it's balanced. Can. So far so good. All balanced. Okay, next step two. Step two. Oh, I forgot one thing about the thing. I know you must write the add in balance chemical equation. Okay. So let's check balance equation, this symbol, all right. Okay, next. Step two. Step two, yeah, step two. For step two, we are going to, I don't know what you call it. You can call it split, or you call it the word ionize. So you got ionize all the aqueous species. I repeat, all the aqueous species. All the aqueous thing you go and ionize. What is that talking about? That I will tell you lah. Okay, so aqueous. That's where the state symbol come into play. The rest, solid, liquid, and gas, we will not bother them. Okay, so what happens now is let's go back and I can choose my color to green. Green. Okay, so just like Mr. mentioned, right? The liquid, solid, gas. We are not going to bother them. So by liquid, I will not bother it. It will just be there. Okay, on its own. Okay, next, I will border those equals. So by equals, I will start to border that. Okay, so for HCl, okay, yes, HCl, I will split it into the ions. I mean, HCl will be H plus and Cl minus. Oh, okay. Then NaOH is Na plus and OH minus. Okay, I'll split them. Oh, yeah, so you split Na plus and OH minus. The state symbol follow the original. So NaOH equals anyway it has to be equals. You only split the equals. That's the rule. Ionize all the equals species. Ionize equals. Okay, so the next one is sodium chloride. I also do the same. Because it's equals, I need to split. So I repeat, equals, you go and split them the ions. The solid liquid gas, don't bother, just keep them original as of original. Okay, so you get that whole long chunk of ions. Next, you go to step 3. Step 3, they ask you to cancel the light ions. Okay, what do I mean by light ions? Okay, I show you. This is the arrow. This is the arrow. This is the arrow. This is the arrow. Okay. Okay, so I have the left hand side and the right hand side equation. The left hand side and right hand side. So you take a look, you can cancel this out because on both the left hand side and right hand side, they are the same. Cl minus bracket EQ. I also cancel this thing out because it's the same Na plus bracket EQ, right? The same one on the left, same one on the right, so they cancel each other. So I cannot cancel H plus because there's no H plus. Okay, on the other side. I cannot cancel OH minus because there's no OH minus on the other side. So what I have at the last part, I just leave them and come back together. This will be my answer. Oh, sounds simple. So sounds complicated. I think it sounds complicated. That's okay. Yeah. Any issue? Issue. Okay, let's move on. Okay, this one, can you put I don't know, maybe as many stars as you can. Okay. Mr. V got mentioned, right? The most important is periodic table. After the periodic table, the second most important thing is that polyatomic ions table. This is the third most important table. I don't know how you're going to do it. You have to memorize them. Okay, really. Okay, this will answer all your questions. How do I know when something is soluble? How do I know when something is insoluble? Am I going to memorize everything? This is how you gonna know something soluble or insoluble. So you look at this, they will tell you the answer. Okay, let me run through with you. So what is Na plus K plus? All these are sodium, potassium, ammonium. All are soluble. I call them SPA. Why SPA? Because sodium, S for sodium, P for potassium, A for ammonium. Ammonium, not aluminium, ammonium, SPA, SPA in short. So as long as SPA, SPA, means that SPA is sodium chloride. Sodium chloride is soluble. SPA, it starts with sodium. Potassium chloride also, ammonium chloride also. So I have sodium chloride, potassium chloride, ammonium chloride, all are soluble. So it's SPA, SPA. Then sodium sulfate, potassium sulfate, ammonium sulfate. All these are soluble. Okay, what is SPA, SPA, SPA. Okay, next, nitrate. Nitrates are all soluble, like sodium nitrate, magnesium nitrate, calcium nitrate, aluminum nitrate. What else? Copper 2 nitrate, zinc nitrate, iron 2 nitrate, iron 3 nitrate, whatever nitrate, as long as nitrate is soluble. You must remember. Okay, chloride. Chloride is all are soluble except for two of it. These are the two exceptions. What is these two? It's called silver chloride. It's the we never spell. Because yeah, spell too long already. Then cannot fit into the box. Silver chloride. The other one is lead 2 chloride. Okay, their formula is there. AgCl and PbCl2. So silver and lead, they are insoluble. The rest of the chloride, sodium chloride, magnesium chloride, calcium chloride, zinc chloride, iron 2 chloride, iron 3 chloride, what else? Whatever chloride. As long as it's not silver and lead, whatever chloride you have, they are all soluble. Okay, silver chloride is insoluble. Lead 2 chloride is insoluble. So their state symbol is bracket S. They are solid. They cannot dissolve in water to give it equals. So it will always be a solid. Bracket S. Okay, chloride. I'm done with chloride. Okay, let's move on to the sulfate. Sulfate also long story. All sulfate are soluble except for that 3. That 3 is what? That 3 is lead 2 sulfate. Yeah. Okay, barium sulfate. And calcium sulfate. You go memorize, okay? Yeah. Last time I was a student, I remember that CLB. Or now it's called BCL, basic Chinese. So CLB, C is calcium sulfate, lead 2 sulfate, barium sulfate. So this CLB, they are insoluble. The rest of the sulfate are soluble. Sodium sulfate, magnesium sulfate, iron 2 sulfate soluble, zinc sulfate soluble, aluminum sulfate soluble. All sulfate soluble except for these 3. Okay, then it will be insoluble bracket solid state. Carbonate, they know carbonate, they swap all are insoluble except for SPA. Yeah, obviously, because you know it contradict the first one. So all are insoluble, everything about carbonate, calcium carbonate. Just like I got do one calcium carbonate, bracket F. Calcium carbonate insoluble, magnesium carbonate insoluble, zinc carbonate insoluble, iron 2, iron 3, all insoluble except for SPA. SPA must be soluble. Sodium carbonate soluble plus SPA. Potassium carbonate soluble. Ammonium carbonate soluble. All these 3 are soluble. SPA, your first rule. Okay, then let's look at hydroxide. 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 Just same thing as carbonate. Same story. Lead 2 compounds. Okay, all the lead 2, whatever, lead 2 chloride, lead 2, whatever. All these lead 2 sulfate, lead 2, whatever, are all insoluble. Except for, of course, lead 2 nitrate. Because all nitrate must be soluble. So lead 2 nitrate is the exception. Otherwise, all the lead 2 something is lead 2 whatever is insoluble. Can. I don't know how you go into it, go and memorize. Okay, next one. How to do this one? Okay, I give you 5 minutes. Go and do the part A only. So, take for you. Do this too. Okay, but to save you the trouble, I give you a chemical equation. Since our focus here is on the ion equation. Let's do I give you the answer for the chemical equation. But if you do not write this chemical equation, you're in trouble. This is acid plus metal giving salt and hydrogen gas. Okay? Yeah, acid plus metal giving salt and hydrogen gas. So the salt is magnesium chloride. If you have trouble, you can write a word equation to help you. If you do it in your head, the word equation, then no problem. So acid with metal is salt and hydrogen gas. The salt is magnesium chloride because I'm using magnesium metal and chloric acid, so it's chloride. We are not done here. We need to balance. Okay. Okay, now you can start. I have balanced already. Oh no, cannot start. You still need to write this symbol. Yeah, that's the symbol. Okay, this equals all SCR equals this metal solid. This one obviously hydrogen and gas. This one, you go and check. Check. Magnesium chloride here. So it's soluble. It will dissolve. It will become AQ. Okay. AQ. Equals it's soluble. It's not a silver chloride anyway, so the one then is insoluble. Then you go and do your ion equation. Okay. How do you do? Wow, so difficult. Okay, first, all the equals must split. So I will split the first one. I'll get H plus and Cl minus. EQ, AQ. Okay? And so I split my hydrochloric acid. But can you take note? Because it's two, there's a two sets of HCl. So I must have, after you split, also must have two sets. I rewrite this one 2 crime already. So I H plus AQ plus Cl minus AQ. Sorry, it was Cl2. Cl minus AQ. So I split the H plus, I split HCl and H plus and Cl minus. So I have a 2, 2, 2, 2. Yeah. Can. Okay, my next one is magnesium. Magnesium don't split. It's solid. Solid don't need to do anything. Just copy. Okay. Okay, next. MgCl2. You need to split because Mg is 2 plus. Cl is Cl minus. Cl minus. But then there's a 2 in front. Why? Because it's MgCl2. There's 2 chlorine to begin with. You're using 2 chlorines. In the MgCl2. So you have to put 2 chloride. Okay, next, hydrogen H2. Don't need to do anything. Okay, now I change my color of my marker to orange. Okay, you will know that this is supposed to cancel out. Because they are exactly equal. No, they are exactly identical. Okay, so I will be left with this answer. This is my answer. Any question? So far so good. Can do lah. Okay, how much time I left? I also don't know. I will calculate. I think not much time. Okay, we will not continue for now. I will write down the answers for this. You can go back and take a look. Okay, HCl. Sodium carbonate is Na2CO3. H2. Okay, acid carbonate give me salt, carbon dioxide, water. Okay, so the next thing is balance. Put a 2 here. I put a 2 here. Okay, it's balanced. State symbol EQ. Okay, this one. Yes, spa is soluble. Okay, but however, the question put solid, so it's solid. I'll explain next time. Equals G is for gas. That's solid. Good. Okay. So let's start. This will be H plus 2H plus 2Cl minus plus, this one don't need to split, thankfully. This one need to split, 2Na plus equals and 2Cl minus equals and then plus CO2. Gas don't need to split, H2O, which is we don't need to split. So after that, I need to cancel. Where's the cancel? Cancel what? Cancel this one. Then nothing else to cancel already. So this is my final answer. Okay, 2H plus equals A1. I will put equals here. Plus Na2CO3 solid. Give me 2Na plus equals plus CO2 gas plus H2O liquid. Okay, I'm done. Okay, my last one. Last one. I just tell you the answer is this one. H plus equals plus OH minus equals UH2O. Believe me, you can work it out. Okay. Any check. So far so good. So far so good. Okay. For the sake of this, I will not continue. I mean, one off time. Okay. Yeah. Okay. Oh. Any question? This one. This one. Just now the answer. H plus OH minus equals PH2O. Okay. This is neutralization. I don't know what you know what's neutralization, but it's neutral ionic equation for neutralization. So as long as neutralization, it will be this equation. But make sure you know what's neutralization. Then you will write. If you don't know whether it's neutralization or not, you better don't know anyhow, right? You gotta go through the steps. Okay. Okay. I think I can stop share. Finally. Yeah, finally stop share. Stop. Okay, thank you very much. That's the end of the thing. Bye bye.